Alright, so exercise 13.1, question number up to questions from 1 to 5 are really very simple. So let's start doing from question number 6. It is, what are we supposed to find out? We are supposed to determine P of E given F, and now in case 1, E is given. What is the question? A coin is tossed 3 times. So what are the outputs we can get? So what will be the sample space in case 1? You can get all H, 2 H and 1 tail, H T H and T H H. Then we can have 1 head and 2 tails, then tail head tail, then tail tail head, and finally T T T. So you have a total of 8 outcomes, right? Alright, so here E is defined as a head on the third toes. So how many such possibilities are there? Head on the third toes. Head on the third toes means okay, so head on the third toes means you have this one, then this one, H, T, H. Here also there is a head on the third toes, T, H, H, head on the third toes. Anything else? No. So there are 3 possibilities for E. Now, do we need to find N of E? Not necessary, because that's not needed. Next we have F. What is F given as? Head on the first 2 toes. Head on the first 2 toes is H, H, H and H, H, T. So there are 2 such possibilities for this one also. Alright. Now, what is the probability of getting F? Is 2 out of a total of how much? Total of 8. So that is 1 by 4. What is E intersection F? What are the things common here? There is only H, H, H is common. Nothing else is common. So E intersection F is H, H, H. So P of E intersection F is 1 by 8. Okay, so these are the required informations we need. P of F and P of E intersection F. Now, P of E given F is equal to P of E intersection F divided by P of F, which is, what is P of E intersection F? 1 by 8 divided by 1 by 4. So this will be 1 by 2. Alright, so that is question number 6, first part. Let's go to question number 6, second part. Alright, in the second question, E is an event. E is an event where you have there is at least 2 heads. So H, H, H is a possibility. T, H, H is a possibility. H, T, H is a possibility. And H, H, T is a possibility. Then you have 2, then we start with 2 tails. But we need at least 2 heads. So this is finished here. In the second condition, what is it given? At most, at the maximum of 2 heads. So let's say all tails, 2 tails and 1 head. Tail, head, tail, head, tail, tail. Then we have at most 2 heads, that is 1 tail and 2 heads, or head, 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 tail, head, and head, head, tail. Okay, so how many outputs are there? 3, 4, 5, 6, 7. So probability of getting F is 7 out of 8. Alright, what is E intersection F now? E intersection F is, let's look at things that are common. So at most 2 heads, so this will be there. Okay, that's the only thing common, right? So E intersection F H, E intersection F will be T H H, H T H, H H T. Okay, so P of E intersection F will be 3 out of 8. Okay, so next, P of E given F is equal to P of E intersection F divided by P of F. P of E intersection F is 3 by 8 divided by 7 by 8. 8 cancels. Your answer will be 3 by 7. Done. Let's go to the third part. In question number 3, E is given as a condition where you can have at most 2 tails. So you can have a condition of no tail, or you can have a condition of 1 tail, or you can have a condition of maximum of 2 tails. Alright, so how many numbers are there? There's a total of 7. So we don't need that, but we need F. What is F given as? At least 1 tail. So the only condition that we eliminate is all heads is eliminated. So all other terms will come. So P of F would be 7 out of 8. What would be P of E intersection F? E intersection F will be everything except head, which means intersection F, there will be 6 terms out of 8. So P of E given F will be P of E intersection F by P of F. E intersection F is how much? 6 divided by 8 divided by 7 divided by 8. You cancel, you get the answer as 6 by 7. Alright, in question number 7, we have 2 coins that are tossed once. 2 coins tossed once means what will be the sample space? Let's say this is first coin, this is the second coin. You can have HH or HT or TH, then TT. Okay, this is the first possibility. This is the total possibilities. Now, what are the given conditions in question 1? E is an event where tail appears on one coin. Tail appears on one coin means HT and TH can come because tail is appearing on one coin. Alright, and what is F given as? F is that condition where one coin shows head. Okay, again one coin shows head. Alright, here P of F is 2 out of 4, which is 1 by 2. Similarly, E intersection F, since E and F are same, is also HT and TH. So P of E intersection F is also 2 by 4 is 1 by 2. So P of E given F is P of E intersection F by P of F, which is 1 by 2 divided by 1 by 2. The probability is 1. There is 100% chance that you get this conditional probability. Let's go to next question. In the second question, E is a condition where no tail appears. So there is only one such possibility, which is both should be H. And F is a condition where no head appears. That is, both are tails. Alright. So what is P of F? It is 1 by 4. What is E intersection F? Is 5. So P of E intersection F is 0. So P of E given F is P of E intersection F by P of F, which is 0 by 1 by 4. Your answer is 0. There is no such possibility for this to happen. Alright, let's go to question number 8. In question number 8, a die is thrown 3 times. So let's say if the die is thrown 3 times, then what are the possibilities What are the possibilities we have? First can be filled in 6 ways. Second can be filled in 6 ways. The third position can also be filled in 6 ways. So there is a total of 216 possibilities here. Okay. Now, what is condition E given as? 4 appears on the third row. If 4 appears on the third row, which means 4 is filled, this row is filled with 4, and you can't change anything about this. So 4 is completely filled. So the next 2 can be filled in how many ways? This can be filled in 6 ways. This can also be filled in 6 ways. So there is a total of 36 different possibilities in this case. Okay. And F is that condition. You can't write the whole possibilities because it is not necessary. Let's discuss what is the condition F given. F is a condition where 6 and 5 appears respectively on the first 2 choices. Okay, respectively it is said, which means 6 and 5 is also locked. So here it will always be 6, here it will always be 5. This condition is locked. Then this can be filled in only how many ways? All the other 6 numbers can be included, so this can be filled in 6 ways. So probability of F is 6 out of a total of 216. Don't cancel, it will be. Now let's discuss what are the possibilities here. You can have 651, you can have 652, 653, 654, 655 and 656. You don't have to write it, but I'm writing it just so that you can understand things better. Now what is E intersection F? E intersection F should be common in both. Alright, so whatever is in E will end with 4. So the only number that only possibility that ends with 4 in F is 654. So E intersection F is only 1. So what is P of E intersection F? It is 1 out of 216. Alright, right. Now P of E given F is P of E intersection F divided by P of F, which is 1 by 216 divided by 6 by 216. This cancels and you find the answer will be 1 by 6. Alright, clear? Yeah, let's go to question number 9. Okay, so in question number 9, it says mother, father and son line up at random for a family picture. Okay, so how many elements are there? Mother, father and son line up for a family picture. So let's say if they stand in this order, mother, father and son, then this can be filled in 3 ways. Mother, father or son. Since repetition is not allowed, this can be filled in 2 ways. It can be filled in 1 way. So there are a total of 6 different possibilities. That is the total possible outcomes is 6. Alright. So case 1 is sun on one end. Okay. E is that condition where sun comes on one end. Okay. So maybe the sun can come first. It can be S, F, M. Okay, sun, father, mother, or it can be sun, mother, father. This is when sun is in the first position. What if sun is in the last position? Then you can have mother, father, son, or father, mother, son. Okay. What is condition F? We don't need the probability for P of E. We don't need that, but let's move to F. What are the possibilities for F? Father in the middle. Alright, if you put father in the middle, then son can come first, then comes mother. Or mother comes first, then father, then son. Okay, so these are 2 possibilities. So P of F is required, which is 2 out of a total of 6. Don't cancel, let it be like this. Okay, now tell me what is E intersection F. The common terms in both is father coming in between. Father coming in between means father is standing between mother and son. So there are only 2 possibilities. Okay, so N of E intersection F is this. P of E intersection F will be 2 out of 6. Right? Okay. So in this case, P of E given F is P of E intersection F by P of F, which is 2 by 6 by 2 by 6. The answer is 1. Okay? Yeah. So that's done. Let's go to question number 10. In question number 10, there is a black die and there is a red die. So there are 6 possible ways of black dies and there are 6 possible ways of red die. So there is a total possibility of 36. Okay. So what will be the sample space looking like? It will be 1, 1, 1, 2, 1, 3, etc. Then you have 2, 1, 2, 2, 2, 3, etc., etc. up to 6, 6 is your possible sample space. Now, what is the first one? First condition. Find the conditional probability of obtaining a sum greater than 9 given that black die resulted in a 5. So black die resultant in a 5 is the given condition. Okay. Sum greater than 9. When does the sum greater than 9 part start? You can get it as can you take 3, 6? No, that in that case sum will be equal to 9. So greater than 9 is 4, 5. Then you have 4, 6. After that 5, 4, 5, 5 and 5, 6. Then you have 6, 6. Okay, these are all the possibilities where the sum is greater than 9. Alright, do I need probability of E? No. Then what is F? Given that the black die resulted in a 5. Black die, let's say we are considering the first element to be from the black. So that is already 5. So the possibilities are 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. Right? That's the only condition given that the black die resulted in a 5. So in this case, P of F is equal to, how many elements are there? 1, 2, 3, 4, 5, 6. 6 out of 36. What is E intersection F? E intersection F is we look for common. So it has to be 5, 4, 5, 5, 5, 6. Alright, so there are only 3 elements. So P of E intersection F will be 3 out of 36. Okay. Right. 3 or is it 2? It has to be greater than 9. If this 5, 5, 4. Oh, by the way. So in question number 10, there is a black die and then there is a red die. So black die, there are 6 numbers. Red die also there are 6 numbers. So there is a total possibility of 36. Okay, there is a total possibility of 36 outcomes here. Okay. So in the first question, what is the condition? Find the conditional probability of obtaining a sum greater than 9. Sum greater than 9 is when do you get 9? 3, 6 will give you 9. But we can't take 3, 6 because we need a sum greater than 9. So we have to go to 4. Okay, 4, 5 I cannot take. I want it greater than 9. So 4, 6 is a possibility. Then I go to 5. Then 5, 4 cannot be taken. 5, 5 can be taken. 5, 6 can be taken. Then 6, 6 can be taken. Alright, so that's a total of 4. Do I need the probability? No. What is the conditional probability given? Given that the black die resulted in a 5, which means here I am considering the first element to be from the black die. So that is 5. So what are the possibilities? 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. So these are my possibilities for f. So what is probability of f here? That will be 1, 2, 3, 6 out of a total of 36. Alright. What is E intersection F? Common terms. What are common? The first element is 5 and it has to be greater than this. So there are only two elements that are common. So P of E intersection F is 2 out of 36. Now P of E given F is 2 by 36 by 6 by 36 is 2 by 6 is 1 by 3. Alright, let's go to part B of question number 10. Alright, so in part B, we have find the conditional probability of obtaining the sum 8 given that the red die resulted in a number less than 4. Okay, so in this case, I'll draw the first die to be red and second one to be black. Okay, so let this be red. Okay, so what are the total possibilities still? It will be 6 possibilities here, 6 possibility here. So that's a total of 36 possibilities. Alright, what is the condition A given as? Find the probability of obtaining the sum as 8. So when do you start getting 8? You get 8 at 2, 6, correct? Then you have 3, 5, 4, 4, 5, 3 and 6, 2. I don't need the probability of that. And F is that case where the red die resulted in a number less than 4. What are the numbers less than 4? 1, 2 and 3. And you will get combinations like 1, 1, 1, 2, 1, 3, etc. up to 1, 6. Similarly, because it says red results in a number less than 4. Okay. The second number is 2, 1, 2, 2, etc. up to 2, 6. 6 elements there. Then we have 3, 1, 3, 2, etc. up to 3, 6. So there's a total of 18 elements. So what is P of F? P of F is equal to 18 divided by 36. Let it stay. Now P of E intersection F is equal to, how many such terms will be there? It has to be starting with a number less than 4. How many such numbers are there? 2, 6 and 3, 5. There are only 2 such possibilities. So that will be 2 out of 36. Now P of E given F is P of E intersection F by P of F, which is, what is P intersection F? 2 by 36 by 18 by 36. So when it cancels, you get the answer as 1 by 9. Please write down.